Okay, just to recap where we left off. So we started with this forced harmonic oscillator where our forcing function was sine of 2t. And we observed that that's the imaginary part of e to the 2it. So we created this second order differential equation in an unknown complex valued function. We said we complexified the equation. Okay? We said if I can solve this, and this one's nice because there's an exponential involved, if I can solve this, my particular solution to this is just going to be the imaginary part of my particular solution to the complexified equation. So we had made a guess that the particular solution to our complexified equation was going to be a copies of e to the 2it. We worked out what a was, and we determined that it was 1/40th minus 3/40th I, a lovely number indeed. Okay, so now we've got our particular solution to the complexified equation. We just need to work out what's its imaginary part, because that's going to give us our particular solution to the real valued equation. Okay, and we'd already done the work. We know that the general solution will be a solution to the associated homogeneous equation. We found that fairly easily, plus this particular solution that we're looking for, which we're going to put right there to fill in that blank. Okay. So what I need to do is just apply Euler's formula so that I can FOIL this out and figure out what parts are real and what parts are imaginary. So this is 1/40th minus 3/40th I times e to the 2it is cosine of 2t plus I times sine of 2t. Okay. Now, when I FOIL that out, I'm going to get 1/40th cosine of 2t plus 1/40th I times sine of 2t. Now I'm just going to underline that because that's going to be part of the imaginary part. Minus 3/40th I times cosine of 2t. I'm going to underline that because that's part of the imaginary part. And then this is going to be minus 3/40th I squared, but I squared is -1. So that's just going to be plus 3/40 of sine 2t. Okay. All right, now, if I wanted to be super lazy, I could have said, I don't even need to multiply out what this is and what this is, because those are going to give me real pieces. I only want the ones that are going to be part of the imaginary part. Okay. So remember, the imaginary part is the real valued function that gets multiplied by I. So now I can see, actually, you know what? I'm just going to write this whole thing out. 1/40th cosine of 2t plus 3/40th sine of 2t plus plus I times 1/40th sine of 2t minus 3/40th cosine of 2t. So this right here is my y tilde sub real, and this right here is what I wanted, yp, my yp tilde sub imaginary. Now, if you're comfortable picking that out from here without writing out the whole thing, that's totally fine. This was our first time doing it, so I thought it made sense to do that. So that means that's my particular solution. So I can fill in 1/40th sine of 2t minus 3/40th cosine of 2t. So as we suspected, we do just end up getting some sines and some cosines. Okay. So remember, that's our particular solution. With this forced harmonic oscillator, that's also going to be my steady state solution. So what that means is that as time goes towards infinity, all solutions are going to start to look like this. The end behavior, it's going to be almost indistinguishable from this function, and that's just because this part is going to go to 0 as t goes off to infinity. Okay. Now, if you were asked to graph that steady state solution, let's remember that we could do that. What we would want to do if we were graphing that steady state solution would be to write that as a transformation of cosine. So let's just review how to do that. So we've got yp, which is 1/40th sine of 2t minus 3/40 cosine of 2t. That's my steady state. You can call that my steady state response or my steady state solution. All solution curves approach that as time goes off to infinity. Now if I wanted to graph that, I'm going to remember that I'm going to use this nifty triangle where I put a phi here. The coefficient in front of cosine I put on the horizontal part. The coefficient in front of sine I put on the vertical part. And this I'm going to call C. Or I can call it K, whatever I want, doesn't matter. Okay, and then this is going to equal C copies of cosine of 2t minus phi. So I can view this as a transformation of cosine. I just need to figure out what's my C and what's my phi. Okay. Now this is of course a symbolic triangle because triangles don't have negative sides, and there's no saying that phi has to be an acute angle. This is just a mnemonic device to help me calculate things. But C is essentially what the hypotenuse would be. So C is the square root of 1/40 squared plus negative 3/40 squared. That's going to be the square root of 10 over 40. Okay. Now for phi, what I can see is that tangent of phi is going to be 1/40 over negative 3/40, and that simplifies to just negative 1/3. Be careful though, there are infinitely many solutions. I need to make sure that I pick a solution that lands in the right quadrant. So, if I actually plot the point, negative 3/40, 1/40, each of these tick marks is 1/40, that's going to land me in quadrant 2. My phi has to be an angle in quadrant 2 whose tangent is negative 1/3. Okay. So it's always, again, the number in front of cosine. I associate cosines with x's, so that goes on the horizontal side. The number in front of sine, I associate sines with y's, so I put that on the vertical side. Okay. All right. So basically then, I'm going to let that be my alpha. Now that's not an angle that a value of tangent that I recognize. I can tell that my reference angle alpha is not going to be pi over 3, pi over 4, or pi over 6. But what I do know is that tangent of that reference angle will be the absolute value of negative 1/3, which is 1/3. So the reference angle is just arctan of 1/3. Can't use arctan for phi because it's not in the range of arctan, but the reference angle always is. Okay. So phi would just be pi minus arctangent of 1/3. So this is root 10 over 40 times cosine of 2t minus this quantity, so I'm just going to distribute the negative, minus pi plus arctan of 1/3. Okay. So if I wanted to graph that, then I'm just graphing that transformation of cosine. And I'll remind you that there is a PowerPoint listed under handouts that you can look at just to review how to graph transformations of cosine if you're feeling a little bit shaky on that. Okay.